Hello, future engineers. Welcome to my YouTube channel. Here is another lecture video and sample problems, continuation part 3 of advanced mathematics. So here we go. Problem solving. Problem 5. For the vectors A, 24i minus 18j plus 27k, and B, 21i plus 7j minus 32k, determine the angle between them. So we can find this by obtaining the dot product between the two vectors. The magnitude of the resultant vector, we add them, then obtain the resultant vector, then the magnitude is square root of the sum of the squares of the components. Then A cross B, I will introduce technique on how to define A cross B and the area of the triangle formed between A and B. The magnitude, 1/2 of the magnitude of A cross B. That's the area of the triangle. So for the angle between them, A dot B is simply 24 times 21, remember that product, plus negative 18 times 7 plus 27 times negative 32. Or you can use your calculator and define these two vectors and from there get the dot product to find the angle between them. So A dot B is AB cosine theta and A dot B is 24 times 21 plus negative 18 times 7 plus 27 times negative 32. And that is equal to negative 486. The magnitude of A is square root of 24 squared plus 18 squared plus 27 squared. And that magnitude of A is equal to 3 times square root of 181. While the magnitude of B is square root of 21 squared plus 7 squared plus 32 squared. And that is equal to square root of 1514. Substitute into this formula, negative 486 is equal to quantity 3 square root of 181 times square root of 1514 cosine of the angle between them. So the angle between them is 108.0 degrees to 4 significant figures. The accurate value is 108.027 degrees. We will use that value, accurate value, in computing the area of the triangle formed between A and B. The next is the magnitude of the resultant vector. A plus B is 24 plus 21, so that's 45i, negative 18 plus 7, negative 11j, 27 minus 32, negative 5k. The magnitude of the resultant, therefore, is square root of 45 squared plus 11 squared plus 5 squared, and that is equal to 46.59. Then part C, A cross B. So for A cross B, we write the components of A just like evaluating determinants in matrix form. Components of A, components of B, then the unit vectors I, J, K. Then we copy the elements of the first two columns. So components of A or vector A, components of B, vector B, then unit vectors. Then we copy the first two columns, just like evaluating the determinant of a 3 by 3 matrix by the basket method. Another way is using your calculator, direct way, you define vector A, define vector B, then in the uh, matrix or in vector matrix, you have to operate in your calculator A cross B and it will define these values automatically. But in this case, this is the technique. So for I, negative 18 times negative 32 times I, that's positive 18 times 32, then minus the product in that direction, diagonal in that direction. So 18 times 32 minus 7 times 27 I, and that is equal to 387 I. Then for J, 27 times 21, that's positive. Then minus negative 32 times 24. So minus of negative value is positive. So 27 times 21 minus negative 32 times 24, so that's plus 32 times 24. Then it is equal to 1,335 J. Then finally, for K, 24 times 7, that's positive, minus 21 times negative 18, so that's negative. 24 times 7 minus quantity 21 times negative 18, so negative of negative 21 times 18 is positive, so that it's like 24 times 7 plus 21 times 18, and that is equal to 546 K. So that's A cross B. Let's color it. A cross B is 387I plus 1,337J plus 546K. Then part C, that's part C. Part D, the area of the triangle formed between A and B. So the magnitude of A cross B, half of that is the area of the triangle formed between A and B. So A cross B is area of parallelogram formed between the vectors A and B, but the area of the triangle is half of that. So area of triangle is 1/2 magnitude of A cross B. And specifically, since the magnitude of A cross B is the magnitude of this result, so that is area of triangle is 1/2 square root of 387 square plus 1335 square plus 546 square. The area of the triangle, therefore, is equal to 746.7 square units. Then another technique is from trigonometry, area of triangle is 1/2 product of adjacent sides sine of the included angle. The included angle, to be more accurate, is 108.027. And the sides are A and B. These are the magnitudes already. So area of triangle is 1/2 of quantity 3 square root of 81 AB sine theta. So 1/2 of quantity 3 square root of 81 times square root of 1514 sine of 108.027 degrees, to be more accurate. So using your calculator there, the area of triangle is equal to 746.7 square units, just like that. So that's it for that problem. So next, let's have problem 6. If vector A has this component 7, negative 1, 5, B, negative 2, 3, 1, find the scalar projection of B onto A and the vector projection of B onto A. The scalar projection of B onto A is denoted by B sub A, and this is simply equal to magnitude. This is actually equal to, so A dot B equals AB cosine theta. Since this is B cosine theta, it is A dot B over A. Vector A dotted with B divided by magnitude of A. So B sub A is vector A dot vector B divided by magnitude of A, because that is B cosine theta. B sub A is B cosine theta. So A dot B is simply 7 times negative 2, so negative 14 plus negative 1 times 3, so negative 17 plus 5 times 1. So negative 17 plus 5 is negative 12. So this is negative 12, while the magnitude of A is square root of 7 square plus 1 square plus 5 square. 7 square, 49, 50, 75. And square root of 75 is 3 square root of 5. Therefore, B sub A is negative 12 over 3 square root of 5. So that is A dot B, which is equal to negative 12. And B sub A, this is the magnitude of A, square root of 7 square plus 1 square plus 5 square, square root of 75. And square root of 75 is 5 times 3, 25 times 3, and square root of 25 is 5. So therefore, it is 5 square root of 3. Sorry, I mentioned earlier 3 square root of 5. It is supposed to be 5 square root of 3. So substitute here. A dot B is negative 12 divided by 5 square root of 3. So we rationalize square root of 3 by multiplying square root of 3 over square root of 3. The denominator is 15. Negative 12 over 15 is negative 4/5. Then we have square root of 3. So B sub A is negative 4/5 or negative 4 square root of 3 over 5. Then for the vector projection of B into A, all we have to do is multiply this magnitude with the unit vector of A, which is vector A divided by magnitude of A. Since vector A is 7i minus j plus 5k, then divided by its magnitude, which is 5 square root of 3. So B sub A as a vector is magnitude of B sub A times unit vector of A, 7i minus j plus 5k over 5 square root of 5. Since 7 times 4 cancel square root of 3 over 25 is negative 28 over 25i. Then for j, it's cancel square root of 3. It is positive 4 over 5. And for k is negative, cancel square root of 3. Negative 4 times 5 over 25. And that's negative 20 over 25k. So again, B sub A as vector projection of B into A is equal to, after we cancel 3, we have negative 28 I over 25, then plus negative 4 times negative 1, so 4, cancel square root of 3 over 25, 4 over 25j, then for k, cancel square root of 3, we have negative 4 times 5, negative 4 times 5, negative 20 over 25, so that's negative 4/5, or cancel 5, negative 4 over 5 times k. So that's why this is the answer. Problem 7. We have find the volume of the parallelepiped having vertices at A 130, B 2, negative 1, 3, C negative 2, 2, negative 1, and D negative 1, 1, 2. So we define three vectors as the edges, and we obtain that product. Then the resulting dot product is dotted with the last vector. Remember, that's the volume of the paraboloid, which is in this case can be reduced to parallelepiped. So let's define three vectors: AB, AC, and AD. So volume of parallelepiped is dotting first vector for crossing first vector with the second, A1 cross A2. So remember, the absolute value of this is the area of the parallelogram. Then A3 is the third vector. If we expand this, we have magnitude of A1 cross A2, which is area of the base. Then A3, magnitude of A3, then times the cosine of the angle between this vector and this vector here. And that's the projection of A3, which is the height of the rhomboid. In this case, height of the parallelepiped. So this represents volume. So defining A1 as 2 minus 1, because it is AB, 2 minus 1i, so it's I, negative 1 minus 3, negative 4j, 3 minus 0, so positive 3k. Vector 2, A sub 2 is vector AC, negative 2 minus 1, negative 3i, so that's vector AB. Negative 3i, then 2 minus 3, negative j, then negative 1 minus 0, negative k. Negative 1k or negative k. So this is vector AC. And the last vector A3 is negative terminal minus initial. So negative 1 minus 1, that's negative 2j minus 1 times 3, negative 2k, 2 minus 0, positive 2k. So negative 2i, negative 2j, positive 2k. These are the three vectors. Obtaining the dot product, and to arrange scalar type or tripole product, we have to arrange the components of the first vector in the first row. In the second row, components of second vector, and in the third row, the third vector. And since we are not sure if A1 cross A2 would be positive or negative, we have to make it absolute value. Anyway, this scalar dipole product is the volume of the rhomboid, supposedly, which reduces to a parallelepiped. So copy the first two column elements, 1, -4, -3, -1, -2, -2. And multiplying diagonals down to the right, positive. That's positive, positive, positive. So it is -2. Absolute value of quantity -2. This is -8. This is positive 18. So -2, absolute value of -2, -8 plus 18. Then up to the right would be negative. So minus quantity positive 6, positive 2, plus positive 24. So minus the quantity 2, 6, 6, 2 plus 24. So that is 6 minus quantity positive 6, that's positive 2, and that's positive 24. So evaluating, that's volume of parallelepiped is absolute value of -24, that's -24, therefore the volume is 24 cubic units of the paraboloid. Then problem 8, there are 10 problems here. So use vector cross product to find the equation of the plane perpendicular to each of the planes x minus y plus z equals 0 and 2x plus y minus 4z minus 5 equals 0. And the containing point 4, 0, -2. So all you have to do is define vectors on these planes. So we simply define them by, in this case, I minus j plus k for vector A. I minus j plus k, a vector on the plane, on this plane. And another vector on this plane would be 2i, vector B, 2i plus j minus 4k. Then the third vector would be defined later containing this point. So if this is vector A, that's vector B. If we perform cross product, we define another vector perpendicular to the planes containing these two vectors. So we are satisfying the condition. So this is A cross B, perpendicular to the planes of the two vectors. And we define another vector containing this point 4, 0, -2 and the point x, y, z as shown. So since there's only one, actually you can choose any point on A or on B, but this is the only point, so we select it to be supposedly anywhere, but it is the connection or from the point of intersection of these two vectors. So this is the third vector passing through that point x, y, z. Therefore, that vector, red vector there, which is perpendicular to A cross B, and they are perpendicular to each other. That means that the dot product of A cross B and this vector C here is 0. So call that vector C. So this reduces to scalar dipole product, quantity absolute value or quantity A cross B dot C is equal to 0 because it is magnitude of A cross B times magnitude of C. So there are values, but times the cosine of the angle between them, which is cosine of 90 degrees. And cosine of 90 is 0. So that's why we equate it to 0. So C is x minus 4 quantity I plus y minus 0 quantity j, terminal z minus -2. So z minus -2 is z plus 2 quantity k. So this is the third vector, and A cross B dot C is supposed to be 0. And the technique in A cross B is we copy the components of A in the first row, components of B in the second row, and in the third row, the components of C, x minus 4, y minus 0, or simply y, and z plus 2. So by basket method, we copy the first two column elements 1, negative 1, 2, 1, and x minus 4, y. And apply this technique, basket method. Let's begin with x. Negative 1 times negative 4 is positive 4 of x minus 4. Then minus positive 1 of x minus 4. Therefore, the net value, positive 4 of quantity x minus 4 minus 1 times quantity x minus 4 is 3 times quantity x minus 4. Then for y, we have 1 times 2 times y, 2y. Then minus negative 4 times 1, that's positive 4y. So 2y plus 4y is 6y. So minus quantity. So this is, I'm sorry, it is, the net value should be 3 times x minus 4, but what I did here, I first expand. So negative 1 times negative 4 times x minus 4, that's it. Then minus 1 times 1, so minus 1 of quantity x minus 4. Then for y, this is positive 2y. So positive 2y minus negative 4 times y, so that's 6y. So 2y plus 4y. Then for z, 1 times 1, so 1 times quantity z plus 2 minus 2 times negative 1, so that's plus 2 quantity z plus 2. So 1 times quantity z plus 2 plus 2 times quantity z plus 2. So combining, this is net 0 equals 3 quantity x minus 4 plus 6y, then plus 3 times quantity z plus 2. Distributing, so 0 equals 3x minus 12 plus 6y plus 3z plus 6 equals 0. So finally, we have 3x plus 6y plus 3z, negative 12 plus 6 is negative 6, equals 0. So minus 6 equals 0. Divide everything by 3. All coefficients and this constant are divisible by 3. So the final answer is x plus 2y plus z minus 2 equals 0. So that's it for that problem. Then problem 9, still on this page, this screen. Find the area of the parallelogram with two sides defined by A, quantity 6i minus 3j plus 2k, and B, negative 1 plus 4j minus 3k. So remember that the cross product, the magnitude of the cross product of these two vectors is the area of the parallelogram. So for the technique of cross product, we do this same technique. Components of A first. So 6, negative 3, 2. Then negative 1, 4, negative 3, components of B. Then the unit vectors. Copy the first two column values, 6, negative 3, negative 1, 4, and unit vectors ij. Therefore, for I, negative 3 times negative 3, 9. So 9, positive 9 minus 4 times 2, 8. So that's positive 9 minus 8, quantity I. Then for j, 9 minus 8, quantity I. For j, 2 times negative 1 is negative 2. Then minus negative 18, negative 2 minus negative 18, or negative 2 plus 18 is 16 of j. That's the value combining. Then for k, 24, positive 24, then minus 3, quantity k. So quantity 24 minus 3 times k. Then simplifying, a cross b equals I plus 16j, then plus 21k. So the area of the parallelogram is the magnitude of a cross b. So square root of 1 square plus 16 square plus 21 square. And that magnitude, which is area of the parallelogram, is equal to 26.42 square units. Then problem 10. This is the last. Find an equation of the plane containing the points, 3 points, because 3 points determine a plane. So these are the points. So I'll present two solutions, one by the algebraic way. So the second one is by vector cross products, vector scalar triple product. So the general equation of a plane is ax plus by plus cz plus d equals 0. If we divide everything by a, then this becomes x plus capital B over a. Then we will just denote that as small b. C over a is small c, and capital B over a is small d equals 0. So that there are 3 points, then there are 3 points or 3 conditions. There are 3 unknowns here, b, c, and d, so we can solve for the equation of the plane. So first at negative 2, 2, 2. So negative 2 plus b times 2 plus c times 2 plus d equals 0. Simplifying, this is 2b plus 2c plus d equals positive 2, call that equation 1. Next, at negative 8, 1, and 6. So negative 8 plus 1y plus c times 6 plus d equals 0. Simplifying, b plus 6c plus d equals 8, equation 2. Then finally, we substitute 3 for negative 1 into this equation here. So we have 3 plus b times 4 plus c times negative 1 plus d equals 0. Simplifying, we have 4b minus c plus d equals negative 3. So call that equation 3, and we solve these 3 equations simultaneously. We obtain the following results. So b is negative 2/5, c is 7 over 5, d is 0. Then substitute into this equation here. So we have x plus b times negative 2/5 plus c times 7 over 5 plus d 0 equals 0. Multiply everything by 5, then we can now find the equation of the plane. It is equal to 5x minus 2y plus 7z equals 0. So that's it after we multiply this by 5. The second solution is by scalar triple product. So let us say this is the side, the edge AB, the edge AC. So we define two vectors, we cross, then we can define this first vector cross the second vector. And actually, it may be point A to be solved to be the defining third vector, or B. We consider point B or we consider point C. It's up to you. But I just use A and verify in your free time that if you choose B or C, the results will be the same. So AB is negative 8 minus negative 2, so that's negative 6i. The first vector, that's the second vector. And this is the vector perpendicular to these two vectors here after we obtain the dot product of the first 4 fingers here, correlate towards the second vector, and this is the direction of your right thumb. Try to do that for those who are not yet familiar with vector operations. So 4 fingers in that direction, correlate towards that direction. Your right thumb will point in that direction, and that is v sub 1, vector 1 cross v sub 2. Then we define another vector, so again through A, but not necessarily A, it may be B if you want. Then the second point is X, Y, and Z. Or you can choose point C instead, but as long as the second point is at X, Y, Z. So this red vector is equal to vector 3 perpendicular to the planes and this vector here, and therefore that is x minus negative 2, so x plus 2i, vector 3, y minus 2j plus z minus 2, quantity k for vector k. So for vector 1, as I said, it's negative 8 minus negative 2, so that's negative xi. So this is our guide formula, scalar triple product, and equate it to 0. So vector 1 is negative 8 minus negative 2, so that's negative 6i. 1 minus 2, negative 1j. Terminal 6 minus 2, so plus 4k. Vector 2, 3 minus negative 2, so that's 5i. 4 minus 2 plus 2j, negative 1 minus 2, negative 3k. And vector 3 is quantity x plus 2i plus y minus 2j plus z minus 2k. Then we copy this as elements of the first row of the 3 by 3 matrix. We just use absolute value. Then 5, 2, negative 3, then x plus 2, y minus 2, z minus 2. Then we copy the elements of the first two columns. Then we have negative 6, negative 1, 5, 2, and x plus 2, y minus 2. Then for x, we have negative 1 times negative 3, positive 3 of quantity x plus 2. Then minus 2 times 4, negative 8 of quantity x plus 2. 3 times quantity x plus 2 minus 8 times quantity x plus 2. That is negative 5 of quantity x plus 2. Then for y, we have 4 times 5, 20 of y minus 2 minus negative 3 times negative 6. So that's positive 18. So minus 18 of quantity y minus 2. 20 quantity y minus 2 minus 18 quantity y minus 2 is 2 times quantity positive 2 times quantity y minus 2. And finally, for z, negative 6 times 2 of quantity z minus 2, that's negative 12 of z minus 2. Then minus 5 times negative 1, that's positive 5 of z minus 2. So negative 12 of quantity z minus 2 plus 5 of quantity z minus 2 is negative 7 of quantity z minus 2 and equated to 0. Distribute. So we have negative 5x plus 10, minus 10 rather, then plus 2y minus 4, then minus 7z plus 14 equals 0. Negative 10 minus 4 is negative 14 plus 14, 0. So therefore, this reduces to negative 5x plus 2y minus 7z equals 0. And we multiply everything by negative 1 to interchange. So it becomes 5x minus 2y plus 7z equals 0. So that's it for this video because it's now lengthy.